I think that today we are going to try something very interesting. You probably have heard about OpenGL. Okay. Did you know that there is something called WebGL? Okay. So WebGL is a port to the browsers of OpenGL, and using HTML5 it's possible to access this directly. I'm not going to access it directly. I'm going to use a library, an online library for doing it, because it provides easier access to it, so I don't have to worry too much about some functionality that you usually take for granted, like rendering or texturing or whatever. But I will use this library called ThreeJs. And the purpose today is going to build an application similar to Google Earth, but it's going to be much simpler than Google Earth. So we will see how texturing a sphere goes in reverse. Basically, we start with a flat texture, an image, and we try to wrap it around the sphere and to see how that behaves. This ThreeJs, I definitely recommend it. It has a lot of very interesting applications here. I'm just going to demo this Rubik's Cube that somebody made. If you're interested in games and you want to build games for the web, I think that, I think that this kind of library is very useful for that. Okay, but today the demos are going to go in this demos directory and then Lamad Earth, and first one is going to be projection HTML, and we are going to start already with some existing code here. So we have to see what this code is doing. The page looks like this. So you can see here two axes, a y-axis and x-axis. And actually, if you start to play with the mouse, you're going to see a third axis appearing, the z-axis. So what the code is doing, all the code on this page so far, is loading ThreeJs, this library, and drawing 3 lines from this center stage. With 3 different colors to indicate where the things are going to be drawn. It's initializing these controls. I can use now the mouse to actually pan around, zoom in, and rotate. So there is a lot of functionality that I don't have to implement myself. If I use this library, I can just sort of call some functions from there. Now, going back to the source code, this part here is going to load the ThreeJs library, and I'm using from the example these controls for moving the screen. Our main function sets up the scene, the camera, that's also something important, and the renderer, which displays things. If you don't have that, then everything is just going to be in the memory, some numbers there, but they're not visible. And my own function, draw axis, that is here, it's drawing 3 lines, here, here, and here, and the lines are going to go from 0 to a value length in the x dimension, a value length in the y dimension, and a value length in the z dimension. And the colors are going to be red color, green color, blue color. So very simple function that I added there. You can experiment with this code, but the purpose here is not for you to learn how to do this 3D stuff. It's for us to learn about projections, and we use this as a tool to learn about projections. So I'm not going to go much into details here. You can set it up in your home environment if you are interested to learn more. Okay, so what do we want to do? We want to build, to draw the Earth. And that one starts off with the sphere. So I'm going to make a function here in this in-class section that I highlight there. And I'm going to call it maybe function draw sphere. And I want to draw this sphere, okay, just a second. Yeah, with a given radius. And the radius I'm going to give the same as this value for the axes. So note that the axes are actually having a given length here, and the value of the radius that I give is the true radius of the Earth in kilometers. But of course I can't display this many kilometers on the screen. I have also implemented a function that scales things down so they fit on the screen. So when I draw the axes, I'm going to give a radius for the axes, this length value, how long to draw the lines, and for the sphere I'm going to give a radius, how big the sphere is going to be. But when I call the function so that it fits in my screen, I'm going to scale it down from the true size of the Earth with the same function. And let's see now how this draw sphere function is going to look like. Basically, we need an object for the geometry. And this one is going to be initialized from the ThreeJs library. That contains something called the sphere geometry, and it needs parameters for the radius and two other parameters for something called segments. Let's just put these to 4 for now, and we will see what that actually means. To see the sphere, we need to give it a material. There are many materials available. In the library, I'm just going to use something called Mesh Basic material. And this one has a set of attributes. We are going to set the one for the color. And let's just put it to red for now. Okay. And now that we have this material and the geometry defined, we need to create a mesh. This mesh is going to be it's like a polygon but in 3-dimensional space. So a 3D shape. To do that, we make, for example, okay, do we have here? I have a variable ready for containing this Earth. And the mesh is going to need two things. It's going to need the geometry that it wants to become a surface, and what kind of material is going to put on this surface. And after that, I think that's it. We need to still, I have here a scene object already defined. In the setup scene function. So we still need to add our object to the scene and to render the stage. So this should work if I didn't make any mistake. So let's go back here and see what we have. Okay, so it's not a sphere, it's something red, so we got that right. And if I zoom in, I see that it actually disappears. This is because materials usually are only one-sided in the 3D world. But you can see inside our original axes. So I haven't removed those, they are just inside of this shape. The segments here that I said before is you don't really have a real sphere. You're just going to have a very round polygon in the end. And the more segments that you're going to add here, I'm going to try to move it to 10. Okay, let's keep 4 in one direction. Now it's becoming more spherical here. You can see hopefully 10 points. I'm not going to count them. Let's put 50 points. So, okay. Now this kind of looks like a circle in this axis, but it still has very few points in this axis. So that's why there are two different parameters for this. Increasing both will look more and more round as you go. I'm going to use, for simplicity, define segments here as 50, and I'm going to use this segments value in this function here. Okay, so that's the sphere, but it's not the Earth. So the Earth is going to look a bit different. It needs to have countries and continents and whatever. So I'm going to copy this function for the draw sphere. Maybe we can reuse it later. And I'm going to rename this one on the top to draw Earth and see what it needs to get to look like the planet. And for that we need a texture. This texture is simply, let's try to look at it. It's simply an image. I'm going to go to my images directory here in Llama Earth. And I have 2 images to experiment with. First is what we saw before, this equirectangular projection. And I'm including this Tissot's circles here to see how it will be deformed when we wrap it around the sphere. And the second one is going to be one that looks a bit more like the Earth, because it just keeps the texture from satellite imagery or whatever, wherever it was obtained from. Both of these were taken from Wikipedia. So now I'm going to try with this Tissot variant, and I'm going to try to wrap the texture around it, the sphere, and to see how it looks like. So for that I'm going to need, what do I need here? Okay, I actually need something called a loader. Again, something from ThreeJs library. It's going to be an object that loads a texture from the given URL. And I'm going to tell it to load from images the equirectangular Tissot.png. So that's hopefully the name of the texture, if I didn't make a mistake. And now I have to, the second argument for this load function is going to be a function. This function will be what to do after the texture has loaded. So I'm going to open up a function. The parameter is going to be the texture that has loaded. And inside here I'm going to do something with the texture. And what I'm going to do, I'm going to move the geometry and the material in here, because this is where we're going to define now the new material using this texture. And this basic material may or may not support it, but we are going to use something called a foam material. I'm not sure if the basic one supports texturing. It may or may not, but for some reason in my notes I have this foam material here. So color is not really going to be needed anymore. Instead, we are going to give it the texture. So this attribute called map is going to receive the texture from this argument here. And let's leave it like this for now. Actually, I'm going to make it semi-transparent. I'm going to make the opacity, instead of 100%, I'm going to make it 80% so that we still see these axes in the middle of the screen, through the earth. Okay, and I think that this is it. I just have to rename my draw sphere function from the main to this draw earth, and hopefully it's not working. So geometry is not defined. Okay. Okay. This variable is now being defined here, and probably it's not accessible anymore here. Let's just make sure yeah. So using this debugging console is really helpful to figure out what is going on here. So yeah. Can I zoom in somehow? It tells me now that that the problem is here on this line and that geometry is not defined. So let's try to do this. Add also the objects. Create also the object once the texture is ready. So we will see what that means in a while. And I'm going to refresh the page. Something works. Okay. No more errors here. Yeah. So I'm going to refresh the whole page, and let's see what we have. We still have these controls from before. Yeah, they seem to be okay. The opacity is not working, so I can't see the axes anymore. Let's see if, oh yeah, I'm missing here another argument. I need to tell it that I want to use transparency in the first place. So this is going to be the value for the transparency, but this is going to say, yes, I want transparency or not. And by default, this is set to false. So refreshing it,
you can barely see the axes
through the texture here, but it's good enough for me. So yeah. Okay. Now what do we have? So let's open again our image. And this texture that we are using here. So this is exactly the picture that is being wrapped around the earth. You can see now that these circles here are, the stretched circles from here are not stretched anymore. So basically in this 3D space here, the projection happens in reverse. It fixes the problem that we previously had. You can also see that the straight lines from here, all of these parallel straight lines, actually now meet to this North Pole. So playing around with this can give a bit better understanding about what this equi-rectangular projection, how it is, and what it looks like. Also, the countries, as you go to the north, are not deformed anymore. So they are not flattened anymore, but some kind of blurriness starts to appear. So the more you go to the north, the more fuzzy things start to be. You can see even in the contour of this circle, it looks a bit more blurry here in the northern part. And actually this northern circle is not even a circle here, it's this rectangle that just spreads all over. It just looks like a circle. So anyway, playing around with this should give a better understanding about how these projections look like.